So as I already told you that this will be the last video of this chapter. So in this video we are going to discuss about how to convert a galvanometer into an ammeter and into a voltmeter. Now see, galvanometer means it is a device which detects the presence of current, and it is very sensitive device. Sensitive in the sense, when a small current even passes through it, it shows deflection. Okay, and this galvanometer, okay, just a second. Suppose already I told you in the last video, the thing is like this. Suppose there is a 0 division, okay, then some scale, then division, like this, and these are also the same thing, okay, and there is a pointer. The pointer generally remains at 0 when no current passes through it, but as current passes through it, it shows deflection. Now at very small current, maybe in the order of few microampere, suppose this galvanometer scale, this one, I mean the galvanometer pointer, it shows full scale deflection. Full scale deflection means it comes exactly at the base like this. It shows deflection and it comes here. For a very small current means few microampere, maybe 250 microampere or 300, like that. So we can say that if this galvanometer, if you want to convert it into an ammeter, ammeter measures current. How much current is in a circuit, that is measured by ammeter. So if this galvanometer is so sensitive that only a few microampere current makes the full scale deflection, we have to attach some other instrument with this. We have to attach some other device with it, so that it can allow more current to pass through it, because since it is ammeter will obviously measure more current, maybe milliampere, in the range of milliampere, or in the range of ampere also. So how to convert this galvanometer into ammeter now, because only few microampere current gives the full scale deflection. So what is done with this galvanometer, a small resistance called shunt is connected in parallel, so that suppose now if the whole thing, after connecting the shunt with the galvanometer in parallel, the whole thing becomes the ammeter. And now if this ammeter is connected with any circuit, suppose this is a circuit, current flows through it, from this positive current comes out, okay, this current goes like this, and then here what will happen, there will be division of current. Since this shunt is having a very low resistance, maximum current will flow through this shunt and only small current will pass through the galvanometer. Okay, so that means galvanometer, as we know that it can allow only few microampere current to pass through it, as a result this shunt is doing its work. That means shunt is allowing the rest current to pass through itself, and galvanometer will allow only a small fraction of the current to pass through it. Okay, and the whole instrument now becomes an ammeter. Now it will be able to measure current. Okay, that one, this measurement is a different thing which is not mentioned here, but okay, I'll tell you a little bit of this. Actually you have one practical also related to this. Anyways, the measurement will be like this. Galvanometer, suppose this is 0, and suppose here there are 1 2 3 4 5 divisions. 1 2 3 4 5 divisions are there. Okay, the pointer is generally remains at 0. So what we will do is, first we will see that we are making this whole thing an ammeter. The ammeter of how much range? Okay, suppose ammeter of, okay, here there are 5 division more here, and 5 division here, so total 15 divisions are there. Suppose this is an example. Okay, this much is 5, another 5, another 5, so 15. Okay, and we are making a ammeter of how much range? Suppose 5 ampere, or okay, to make it easy, suppose 15 ampere. We want to make an ammeter out of this galvanometer of 15 ampere range. That means the ammeter should measure maximum how much current? 15 ampere. So we will calibrate this scale. That means there are 15 division, right? So 15 division maximum, how much current it should measure 15 ampere. So one division will give us how much current? 1 ampere. Okay, so when this galvanometer, when this pointer from this 0 it shifts one division this side towards right, then we will understand that through the whole arrangement how much current is flowing? 1 ampere. Though this 1 ampere current totally fully is not flowing through the galvanometer, one part is, I mean the larger part is going through the shunt only, but we have calibrated the scale in this way that since we are making a ammeter of 15 ampere range, and since there are 15 division, one division, whenever this pointer goes one division, we will say that it is measuring 1 ampere current, though this 1 ampere current fully is not passing through the galvanometer. Understood? Maximum part is going through the shunt, but the galvanometer, this is only for measuring purpose. Understood? Okay, so this thing is not here. Actually we will see the equation now, the formula. So suppose the maximum current that the ammeter, means the whole arrangement, can measure is I. So this I current here will get splitted. One part will go through the galvanometer. Which part is going through the galvanometer? This is Ig, current through the galvanometer. So remaining will be how much? I minus Ig, which is going through the shunt. Okay, now see, this part and this part are parallel. So if parallel, that means potential across the galvanometer and potential across the shunt will be equal. Okay, the potential means what? V equals to what? IR. So across galvanometer, what will be the potential? The resistance of the galvanometer is capital G itself. Okay, so the potential for the galvanometer will be Ig into G, means V equals to this formula IR. I means for galvanometer is Ig and R for galvanometer is G. So Ig into G is the potential across the galvanometer, which will be equal to the potential across the shunt. What is the potential across the shunt? Current is I minus Ig, resistance is S, so potential is this one, I minus Ig into S. So from this, S equals to this. So this is the expression for shunt. That means how much shunt we are supposed to connect, and that value of shunt, it actually depends on I. I means the maximum current that the ammeter should measure. In the example that I gave just now, in that example what I said, 15 ampere is the current that the ammeter should measure. So the value of I in that case will be 15. Okay, so depending upon different cases, the value of I will change. Another thing, what will be the effective resistance of the ammeter? Two resistances are connected in parallel, G and S. So their effective will be, suppose R effective. In parallel, how we write? 1 by R effective equals to 1 by G plus 1 by S. So the value comes this one. Okay. So here these two formula you will remember, this one and this one. Next one, how to convert a galvanometer into a voltmeter now. Now see, voltmeter is a device which measures voltage, and the resistance of voltmeter is very high, because if you remember in Ohm's law experiment, there was a resistance, means a wire. You have done this experiment. There was a voltmeter like this, it was connected in parallel, and then the rest part of the circuit. So here, why the voltmeter is connected in parallel with this? So that actually this voltmeter is having a very high resistance. Why voltmeter is having high resistance? The reason is that no current should flow through this voltmeter. If current flows through the voltmeter, then there will be, suppose this is the battery, if current flows through the voltmeter, then through the resistance we will not get the desired amount of current. Suppose here 5 ampere current is flowing, we are also assuming that through this resistance also 5 ampere will flow, but in case this voltmeter draws current, then 5 ampere will not go through this, one part will go through the voltmeter. So that is why this voltmeter must have a very high resistance. Resistance high means what? It will stop the flow of current through it. So that means maximum current, or almost the whole amount of current will flow through this part, not through the voltmeter. Okay, and since voltmeter is having a high resistance, it is connected in parallel. In series, voltmeter cannot be connected because it has a high resistance, so it will not allow current to flow through the main circuit. Okay, so now the thing is that we are converting a galvanometer into a voltmeter. Since galvanometer it has a very small resistance, that means a high resistance or huge resistance has to be connected in series with the galvanometer to convert it to a voltmeter, because voltmeter needs a high resistance. How to get that high resistance? Just connect a high resistance in series with the galvanometer. So the whole arrangement now has become a voltmeter. And the calibration, that means how to take the reading, that is same with the previous one. Means what we did, first we will see, like this is the pointer, this side 15 divisions we have, so we have to see that this 15 division, how much what is the maximum value that this newly formed voltmeter should measure. So this newly formed voltmeter, suppose it should measure just according to the user's wish. Suppose if you want to make it a voltmeter of 10 volt, so that means 10 volt is the maximum voltage that can be measured with the voltmeter. So this 10 volt should be equivalent to how many division? 15 division. So 10 volt is 15 division 10 volt, or in other word we can say 15 division is equal to 10 volt. So 1 division will be how much? 10 by 15 volt. So that will be the value of 1 division. So if this galvanometer pointer shows 1 division reading, then the value will be that much, 10 by 15. Okay, now the calculation part, this part. So from this, the main thing is how much resistance we are supposed to connect. So it depends on how much, what should be the range of the voltmeter that we are producing, we are making. Okay, suppose this voltmeter maximum can measure V potential. So V is equals to what? IR. So I means Ig, the current which is flowing through this resistance as well as the galvanometer, as they are in series, the same current will flow. So Ig into resistance, total resistance. So they are in series, so total resistance will be, resistance of the galvanometer is G and resistance of the high resistance is R, so G plus R. Then just simplification, this Ig will come down, and from this R equals to V by Ig minus G. So this is the expression for new resistance which has to be connected in series with the galvanometer. Okay, and what will be the equivalent resistance of the voltmeter? R plus G, this one. Okay, as they are in series. Then there are two sums related to this topic. Simple one, say a galvanometer of resistance 10 ohm gives full scale deflection for a current of 4 milliampere. Full scale deflection means this is 4 milliampere is the value of Ig. Okay, the maximum current that the galvanometer can measure. Then 10 ampere means a galvanometer of resistance. So this is the value of G, 10. This one. Okay, what else is given? The range of ammeter is given 0 to 5. 0 to 5 means we will take 5, maximum range means this is the value of I is 5. What you are asked to do, how can it be converted into an ammeter? So how means actually you are asked how much shunt you have to connect, that means the amount of shunt you have to find out. So you have this formula, substitute the values, the milliampere you convert it to ampere by multiplying with 10 to the power minus 3, substitute everything, shunt comes as 0.008. So at the last actually you should write that means this much ohm shunt has to be connected in parallel with the galvanometer to convert it to an ammeter of this much range. Okay, write this conclusion. Then a galvanometer having a coil of resistance this is the value of G, 12 ohm, gives full scale deflection, this is the value of Ig, full scale deflection. How to convert, how can it be converted to a voltmeter of range this? So 24 is the value of V. Just simple application of the formula. Remember, how means actually you are asked how much resistance you have to connect. Since this is voltmeter, you have to connect a high resistance in series. So we will use this formula. Substitute all these values. Don't forget to convert this to ampere. Minus 3 should be multiplied. This is the high resistance. So at the last, you write the conclusion. This much resistance has to be connected in series with the galvanometer to convert it into a voltmeter. Okay, so here is the end of this chapter. Next day we will discuss magnetism. That is a small chapter. Let's see how many videos we need for that. Thank you.